Hello and welcome to another video. In this video we're going to be working on count the number of teams. And this one you have n soldiers in a line and each soldier has a unique rating. And you're trying to form teams of 3 soldiers where it's either in increasing or decreasing order without moving the relative order of the soldiers. So in example 1, 2, 3, 4 is increasing, so that's 1. Then we also have 5, 4, 1, that's decreasing, and 5, 3, 1. Example 2, there's none, because these are the only 3, and this is not increasing or decreasing. Here there's 4, so there's 1, 2, 3, 1, 2, 4, and then 1, 3, 4, and then 2, 3, 4. So just say we have all these numbers. And there's kind of 2 ways to do this, and I'll show you like the n squared solution, and then the n log n, I'll talk about it, but I'm not going to code it, because for that you need either it's language specific, that some languages has it, some languages don't, or you need to write something on your own that's pretty advanced, but I'll talk about how to do it. So basically we can say for every number, we can pretend it's the middle of this group, right? So if we want a series of numbers, 1, 2, 3, we can either have it in increasing order, so increasing, or we can have it in decreasing order. So for, like, let's say we're on this number and this is our middle. So we say like, okay, this is a number that has to be the middle. So in order for it to be increasing, there has to be a number smaller than this number on the left and a number bigger than this number on the right. And we can just figure out like how many combinations of that there are. So if there's some numbers that are smaller, let's say here there's 2, and here how many numbers are bigger? 1, 2, 3, 4. So how many combinations can we make? Well, we can pick any one of these 2 and any one of these 4. So this is just 8, right? So we can do like, we can show this really quick. So we can do 1, 4, 8, 1, 4, 9, 1, 4, 6. And then we can also do 2, I think I skipped one, maybe. Maybe. Oh yeah, 10. 1, 4, 10. And then same thing with this, so 2, 4, 8, 2, 4, 9, 2, 4, 6, 2, 4, 10. So hopefully you can see that. Like basically we just have to figure out how many are there on the left we can use, how many are there on the right we can use it and multiply it. That's increasing. We want a number that is smaller than our current number, then bigger. And decreasing we want it the other way. So bigger, current, and smaller. And so we can do that for every number. So for every number, we can just calculate how many numbers on the left are smaller. And then we can also get how many numbers are bigger, because if there's 2 numbers that are smaller and there's 3 total, then we know there's 1 bigger. And same thing for the right. We can calculate how many numbers are bigger, and then whatever the total minus that is how many are smaller. So once we do that, we can just check this and this for the middle number. And then we can do that for every number, and that would be an n squared solution. So we'll just take a couple examples here. So let's say we pick like this number. So we're going to calculate how many numbers on the left are smaller. There are 4. Then how many numbers on the right are bigger? There are none. So here it would be 4 times 0, which is nothing. Now the reverse, how many numbers on the left are bigger? 0. And how many numbers on the right are smaller? All of them, so 5. So there's none and none. So we can't have this be the middle. Now let's say we take this number. So left smaller is 2. Right bigger is 4. Left bigger, just by doing how many there are here minus left smaller, is 1. And right smaller is how many there are here minus how many are bigger, so there's 6 total. 4 bigger, so there's 2. Then we basically take the left smaller, which is 2, times right bigger. That's the increasing. So this is 2 times 4. And then here we have the other version, which is decreasing, so left bigger times right smaller. So for this number to be the middle, we can have 10 total combinations, right? 8 of them are going to be increasing, and there's going to be 2 that are decreasing. The decreasing is 5, 4, 0, and 5, 4, 3. So hopefully that makes sense. So that's how you can do this in n squared. Now the n log n solution involves, for each number, we have to have some kind of sorted container. So let's just say we have like you can't use an array. So in Python, there's sorted lists, which you can do, and sorted lists allow for log n insert. Basically, you need a log n insert and a log n position lookup. So there's sorted lists. There's also, I think, in Java, I don't think there's anything. I think in C++ there's like a sorted multiset, which is basically the same thing. But essentially, if you can have a sorted list, what you would do is you would say, okay, so let me have my item, let me put it in the list. So in this case, if we have 5, let me get the index of it, and then let me figure out like where the other stuff goes. And then you could do this in basically logarithmic time, if that works. So for example, let's say we're trying to put in 10, I guess. Yeah, so 10 wouldn't work. Let's say we're trying to put in 3 and everything else is sorted. So we'd have like 1, 2, 4, 5, 8, 10. Okay, so yeah. So we're trying to put in 3 and everything else is sorted. I think you might need like 2 of these lists now that I'm looking at it. You might need 2, but the basic idea is you try to put in 3, everything else is sorted. You'll say like, okay, 3 is going to go here. That means that to the left of 3, there are 2 numbers that are smaller and 4 numbers that are bigger, because you can do this in log n. Yeah, so I think what you'd have to do is you'd actually have a sorted list of all the numbers that came before, which you can just put in one at a time. And then you can have a sorted list of everything to do the right. And then you would just take the number out. So you'd have another one like this. So let's say this was sorted. So it was like 1, 0, 1, 2, 3, 4, 5, 6. Well, I guess you're basically going to take these numbers out every time as you put them in here. So actually in this case, we're only going to have the numbers that are left after the 3. So like for 3, we'll only have 0, 9, 6. Okay, so we'll basically have 2 of these sorted container things. When we put in the 3, so basically what's going to happen is, I guess I can show it. So for once we're doing the 3, we're gonna it's going to be like this, right? So when we're on the 3, all of these have already been taken out. So basically you're taking the number out of here, and then you know when you take it out of here, like let's say we take out the 3 from here, we know, okay, if we take it out of here, then on this right side, because this is basically what the right side currently has, if we know the index and how many it has, like let's say this is index 1, and if we take it out of here, then we know like there's 1 smaller and there's 2 bigger, just because it's an index of 1 and there's 4 total. So we take out the 3, and then we know that how many right smaller and right bigger are in log n, and then we put the 3 in here. And like I said, there's data structures that do this, but to code one up from scratch, it's like a balanced AVL tree or Fenwick or some other thing that's not a medium problem. So you can either import something, like depending on the language it's built in already, but basically here for this 3, you would say, okay, there's 1 smaller on the right, there's 2 bigger on the right, and then once you put in this 3, it'll also give you the index. So this is index 2, and there are 2 smaller on the left and 4 bigger on the left. And then from here, you can do your calculations. So basically, it allows you to do array inserts and deletes deleting from the middle and inserting into the middle in logarithmic time. So instead of n squared, this will be n log n. So that's kind of confusing. Hopefully that makes sense. You can look up in Python, look up sorted list. I think in C++, it's like a sorted multiset. In Java, there's a sorted set, or there's a tree set, but I don't think it does this, so you have to import something or do some other stuff. And I think it's in the solution, or in the tutorials, like a Fenwick tree if you want to learn it, but I'm not going to do that for a medium problem. I just wanted to kind of give a general overview of how that works. I did use the sorted containers for like some hard problems. I think it's quite helpful, but writing one from scratch is like if you've never done it, it's going to be like pretty hard. So yeah. So let's just code up the n squared solution. So what we're going to do is we'll have our result, and then we are going to loop through every single number. So and then we're going to calculate how many are on the left that are smaller, and then how many on the right that are bigger. And then we can get the other one just by doing the length of that chunk minus what we have. Okay. So we're going to say, we're going to have a j. So we're going to go through everything on the left of this. So we'll say for int j equals 0, j is less than I, So if rating j is less than rating I, that means this is an item on the left that's smaller, so we need that. And then the same thing for the right. So we're going to start at I plus 1, and this is rating length. And this is if rating j is greater than right plus plus. Okay. So now we need to figure out how many we can add to the result. So the result will add how many on the left that are smaller times right that's bigger. And we also want to add the number on the left that are bigger. So the number on the left that are bigger are how many items there are on the left. So if we're at some index I, the number of items on the left is I. And then how many of them are smaller is this. So the number that are bigger is just I minus this. And how many items are there on the left, or on the right, given an index I? So that's going to be rating length minus I minus 1, right? Like for example, if we have an array of length 6 and we're at index 0, there's 5 items on the right. So that's how many items are on the right. And how many items are bigger is this. So we want the number of items that are smaller, so we'll subtract that. Okay, so this is left smaller, right bigger, and this is left bigger, right smaller. Hopefully that makes sense. Or you can just make 2 more variables here and keep track of that if that is easier for you. And then we just return. Okay. Oh, right. All right. All right, and there we go. So yeah, like I said, this is n squared. So theoretically, if you did build like a sorted container or something, it is going to be faster, but the overhead in Java might actually make it not faster in practice. So yeah. So I don't know if there's any solutions to that, but in theory, it should be faster. I guess okay, so they have like some arrays and stuff. All right. And yeah, so this is going to be n squared, because basically for every single node, we're looking at every node. And space. And this is more of like the medium problem version of this, the sorted container and all that stuff. If you import a sorted container, it's not that hard, but writing one from scratch is like a balanced red-black or whatever, it gets complicated. Yeah. Yeah, so I think that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.